Okay, grade 8. In the new topic, we have been speaking about the landforms. And the landforms are the main parts of our world that does not contain water in them. We have spoken about how that the seven continents of the Earth only form approximately less than 40% of our surface, and the rest is just plain oceans and water. Later, we spoke also about how the physical features of the world of our continent are shaped, and we have spoken about the main places of mountains and also great deserts. Of course, there are plenty of deserts on our planet Earth, yet the most or the biggest or the largest desert in the world are the Sahara Desert in Africa and the Gobi Desert in Southwest Asia here from China. You'll study that later. China is here and Gobi Desert is right there. And of course, we have the Great Vectors and also the Great Sandy Desert in Australia. So while speaking about the desert, we have said that we have many forms of the sand that make various shapes, and this is because some various aspects like the wind speed, the wind direction, the quantity of the sand in the place, and the plant cover. So you will find you will have some shape of a mushroom rock, you will have the star dune, you will have the pestle rock, you will have the hamada. An oasis perhaps exists in a desert, and we said that an oasis is an area that is near water source where plants and animals can survive. That's very important. And we have spoken about the sand dunes and all of these different shapes. Okay, so we can find all of these different shapes in the desert, and of course you will not find all of them joined together in that shape. No, but different places with different shapes. But the main features, the main factors that can affect the shape of the sand here in the desert is number one, wind speed, number two, wind direction, number three, the quantity of the sand, and number four, okay, that's great. So, quick quiz. For each definition or explanation, click on the term that matches the best. A dune that forms when wind blows in a straight line is called what? Reef, star, oasis, or rock. Hello? Are you with me? Grade 8, are you with me? Can you hear me? Am I speaking to myself?
Yes.
Okay, I have an idea. I'm gonna call your names. Those who will reply to me will stay in the session. Those who don't reply will be kicked out. عبد الملك المطيري. Safe. Mr. Safe Raji. I'm very concerned. So we have covered the desert, we have also covered rivers, and today we'll speak about the glaciers. So let's speak.
Glaciers. Until recently, ice covered about 10% of the Earth's continents and about 12% of the oceans. Even though this is changing with climate change, our planet still has large areas covered in ice, especially at the poles and on very high mountains. Ice sheets are huge layers of ice. Antarctica is an ice sheet that is bigger than the United States of America. A glacier is a kind of frozen river that usually forms in a mountain valley. As gravity pulls the glaciers and ice sheets downhill, the ice pulls rocks along the land. These erode the land, forming new valleys and riverbeds. Lateral moraine.
So once again, I highlight this one. An ice sheet are huge layers of ice, and the glacier is a kind of frozen river that usually forms in a mountain valley. So once again, an ice sheet means huge layer of ice which covered a very, very large area. And glacier is a frozen river. So let's hear that once again.
Glaciers. Until recently, ice covered about 10% of the Earth's continents and about 12% of the oceans. Even though this is changing with climate change, our planet still has large areas covered in ice, especially at the poles and on very high mountains. Ice sheets are huge layers of ice. Antarctica is an ice sheet that is bigger than the United States of America. A glacier is a kind of frozen river that usually forms in a mountain valley. As gravity pulls the glaciers and ice sheets downhill, the ice pulls rocks along the land. These erode the land, forming new valleys and riverbeds. Lateral moraine. Wall of rubble that collects between glaciers.
So while speaking about the glaciers, you'll have something that is called the lateral moraine. Lateral moraine. Lateral moraines means the wall of rubble that collects between the glaciers. Okay, those are the lateral moraine. We have also the kettle hole. In the kettle hole, you will have a hollow field with water, usually formed by blocks of ice that have been melted. Okay, so this was a huge block of ice, and when summer comes and the sun shines, the heat will melt the ice here, the ice blocks. Consequently, they will make the kettle hole. These definitions are very important, guys, and I will include them in the next quiz. And the drumlins means little raised area that is formed by heaps of sand or red gravel and stones. Drumlins, once again, little raised areas formed by heaps of sand and gravel.
Teacher, your screen has been frozen since 9:55.
And why haven't you told me?
Cause right now they just brought in some like honey.
Trust me, I didn't understand the word, but okay. I stopped sharing the answers again.
Breakfast.
Can you see now?
Breakfast. Yeah, I see the drumlins.
Okay, so we have the rattling moraine, the kettle hole, the drumlins. We have the escarp. The escarp means a snake-like ridge of sand and gravel. We have also the crevasses, which are cracks in the surface of a glacier, like those ones. We have the medial moraine. So we have the lateral moraine and the medial moraine. Regarding to the medial moraine, they are moraines ridge of rubble and rocks that gather at the side of the melting glacier. These definitions are far more important. Sir,
Do we have a quiz today?
request what?
Do we have a quiz today?
No, not today. Next Thursday.
Oh.
What about the movement of the glaciers?
Movement of glaciers. There are two main ways that glaciers move. The weight of the ice forms pressure over the base of the glacier. The pressure heats the base of the glacier. As it melts, it forms a slippery underside, and the frozen river slips down over it. Different layers of ice may move at different speeds. If the top layer of ice is not frozen as solid as the ice underneath, the top layer may slide over the bottom layer, pulling it along as it goes.
So, simply, how does this glacier move? Of course, it's all made out of hard ice. So, consequently, how does it move? Simply, once you go up, the temperature goes down. So the ice here will be less in temperature than the ice there. So this ice now is formed faster and has much mass than that one right here. So because this one is heavier right now, so it put some pressure upon the ice on the middle. And because of this pressure that it pushes it, pushed and pushed and pushed until it starts to move. Because by that push, the ice here, its temperature rises up. Consequently, it starts to move, or even when you have two different layers of ice. For example, the top layer is very, very, very cold. Very, 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 very cold. The temperature is, let's say, minus 19. So the top layer is minus 19. And on the other hand, the beneath layer is minus 14. So the layer beneath will start to move and the layer above will be still. And that's actually what happens in the frozen lakes. You find that on the surface of the lake it's totally frozen. Yet at the bottom there are some fish living in that water. Although that the surface is frozen, or of course vice versa. If you have the bottom layer of the glacier is frozen and the top layer is less in temperature, so the top layer will start moving and not the bottom one. And last is the RT, which is a steep bridge between two glaciers. Any question, grade 8? I believe that's enough. Before we move to the next topic, let's just see a quick movie about Glacier.
Grammarly helps make your writing clear and concise, no matter where you are. Compose a cover letter. In this video, we're going to learn about glacial lake outburst flooding. Recently, this term was in the news with respect to the Uttarakhand. In this video, we're going to learn about Grammarly. Glaciers have been shaping our world for millions of years. But as climate change warms the planet, glaciers are disappearing.
not only altering the landscapes they leave behind, but changing our oceans, weather, and life on Earth as we know it. A glacier is a huge mass of ice that moves slowly over land. Glaciers can be classified into two general groups: alpine glaciers and ice sheets. Alpine glaciers form on mountainsides and move downward through valleys. Sometimes they create valleys by pushing dirt, soil, and other materials out of their way. These glaciers are found on every continent except Australia. Ice sheets, unlike alpine glaciers, are not limited to mountainous areas. They form broad domes and spread out from their centers in all directions. As ice sheets spread, they cover everything around them with a thick blanket of ice, including valleys, plains, and even entire mountains. The largest ice sheets are called continental glaciers. They cover vast areas, including most of Antarctica and the island of Greenland. Glaciers can form over years when more snow piles up than melts. Soon after falling, the snow begins to become denser and more tightly packed. When new snow falls and buries the previous year's snow, the bottom layer becomes even more compressed. The dense, grainy ice that has survived 1 year's melt cycle is called firn. When the ice grows thick enough, the firn grains fuse into a huge mass, called glacial ice. The glacier may begin to move under its own weight through a process called compression melting. As they move, glaciers erode or wear away the land beneath and around them. When glaciers began their latest retreat less than 20,000 years ago, they left behind many landscape features, such as lakes, valleys, and mountains. Glaciers provide people with many useful resources. Glacial till provides fertile soil for growing crops, and deposits of sand and gravel are used to make concrete and asphalt. Many rivers are fed by the melting ice of glaciers. The most important resource provided by glaciers is fresh water. Earth's average temperature has been increasing dramatically for more than a century. Glaciers can act as indicators of global warming and climate change in several ways. Melting ice sheets contribute to rising sea levels. As ice sheets in Antarctica and Greenland melt, they raise sea levels, adding fresh water to the ocean every day. The loss of glacial ice also reduces the amount of fresh water available for plants and animals on land. Large additions of fresh water change the ocean ecosystem as well as ocean currents. Additionally, less salt in the ocean could disturb the Gulf Stream, drastically changing the weather on land as well. Since glaciers are so sensitive to climate change, the increased speed of glacier melt is an early warning system for the rest of the planet. And if global warming goes unchecked, many, if not all, alpine glaciers could disappear completely.
So that's the idea of the glaciers or the glacier. I don't know why all of you are dead today.
Teacher, when do my presentation?
What presentation? Okay. No, can you postpone that? We have another two sessions.
What?
We still have other two
What,
sessions.
teacher?
We still
Okay.
have other two sessions.
They're all dead, teacher.
I beg your pardon?
They're all dead.
Yeah, I can see that. So since you are dead, I'm gonna speak about the mountains. Of course, in the mountains, we all know the mountains, yet there are very different kinds of mountains on our planet. So the mountains mean the plates that form the Earth's crust are always moving. The forces under the Earth's surface can cause mountains to form. It takes millions of years for mountains to form because the land only moves a few centimeters or less each year. So the surface of our Earth is moving, but at a very, 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 very low speed. The crust of our Earth, the layer that we have already studied, okay, moves constantly. Consequently, what happens is that sometimes we will have an earthquakes. Those earthquakes could lead to the new formation of new mountains. So we have the fold mountains. They are the most common type of mountain, which are areas of sea separated to plates of earth. And we have the sediments. Okay. We have also the sediments settle on the top floor between the plates. The sediment forms a type of rock called sedimentary rock. Consequently, as the plates push towards each other while they move, they force the sedimentary rock upward in layers that crumble and fall together to form the mountain. So the process is very easy. So you have the crust of the earth moving, and while moving, it starts to push some rocks upwards. So two different sides are moving, and while they are moving, they are pushing the area between them. But of course, the mountain itself has a very deep layer in the crust. So the tip of the mountain is nothing compared to the rocks beneath it. Other examples are, of course, the Andes in South America and the Rocky Mountains in North America and Urals in Russia. See how the rock here in that picture is formed. So, if you can look at the curves here at the rocks, you will find out that they have been folded to form that mountain. Like there was a huge pressure upon them that led them to curve like that. And this is the folded mountains, okay, because they are being crushed from two sides in order to form the mountain. And I believe you have some here in case. Different kinds of folds are the anticline, you have the syncline, you have the recumbent fold, and the overfold. Last but not least, the volcanic mountain. Of course, a volcano mountain simply means when you have a mountain and at the base of that mountain there is a huge volcano. Perhaps it could be an erupted one, and that might an active volcano or not active volcano. It might erupt, it might not. So volcanic mountains simply means form when a volcano erupts, hot molten rock rises up and spills out onto the land as lava, carrying ash and chunks of solid rock. The rock and lava pile up in layers, forming volcanic mountains. Mount St. Helens in North America, for example, and Mount Pinatubo in Philippines are examples of volcanic mountains, but of course the biggest volcanic mountain in the world is in Japan, Mount Fuji, and thanks God it's not an active one. If Mount Fuji is an active volcano, half of the planet is gonna be destroyed. Sometimes a fold, which is a crack in the Earth's crust, forces part of the land upward. See this picture here, okay? So there is a crack here in the middle, and those two parts are pushing the area between them, leading into rising of some places, or even making a dome because of the pressure from that side and the pressure from that side. We will have that shape, the curved one. So sometimes a fold or a crack in the Earth's crust forces part of land upward or even downward, and instead of bending or folding, the land may sometimes fracture and a chunk of land shifts upward within the main plate. This is a Pluck Mountain. That's the one right here, Pluck Mountain. The Sierra Nevada mountains in North America and the Hard Mountains in Germany are examples of block mountains. Hot magma under the Earth's crust can push upward against the land, causing it to buckle the land upward, creating a dome mountain. So here we have hot lava trying to push up this place. Of course, because you have hot magma and hot lava, they make a very, very big pressure upon the Earth's crust, leading them to rise above. So again, many forms of mountains are being created and formed simply because of we have many factors that can affect them, either by pushing against each other, or by the hot magma or the lava, or by some earthquake and slip in the crust, or the magma is pushing up. And due to that thing, we have those different shapes from mountains. At least, do you understand anything? Any question? Oh my god, you rolled it.